Hi class, these are your notes for 3.3. We're still dealing with summary statistics. Now we're going to focus on measures of center. So we describe 4 characteristics of data using the shape, the center and spread, and outliers. So we're going to talk about all of these things in these notes. So I have a list of data here. It is a list of grades on the 3rd exam for a Math 95 class. And A is asking us to make a histogram of the data to determine its shape. So to make a histogram, we want to label our horizontal axes, which would be our Math 95 exam scores. We could even say 3rd exam scores. And then the vertical axes would be frequency. Okay. So we're going to go ahead and label, this is 1, 2, 3, 4, 5, 6. And our bin size, well, let's see. The smallest we have, 49 is a good contender. So 49. So I'm going to start with 40, go to 50, 60, 70, 80, 90, 100. All right, so let's count how many scores we have between 40 and 50. If I go here, all right, there's 1. So I'm going to list that 1 there. I'm going to keep going. 52 is not in that bin. So it looks like 49, so I have 2. I'm going to do this for every bin just to make sure I account for every exam score so I don't mess up. So now I'm going to look 50 through 60. I'll change colors just to make it a little bit easier. So 50 through 60, we got a 52. That's too big. And we got a 58. So we also have 2 down here. I'm going to get rid of these things in a minute. I'm just using this to make sure I don't miss any values because I'm very good at that. All right, 60 to 70. We got a 67, 66, and 62. So we have 3. And I'm just going to keep with the orange. All right, now I'm looking between 70 and 80. So we get a 74, 1, 2, 3, 4, 5. So we have 5. 80 to 90, 1, 2, 3, 4, 5. And 90 to 100, it looks like we have 96, 1, and a 91, 2. So the reason I did this is now I can see, okay, 2, 4, 7, 12, 17. I should have 19 exam scores. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I like to do that so I don't mess it up. So now I'm going to go ahead because I'll leave 1 off somehow, as you remember my key. So here's 2. Okay, now there's another 2. 3. 5. Okay, another 5. And 2. Now let me go ahead and just get rid of this so you don't think it's part of the histogram. It's just a way to figure it out. All right. So now we are going to use this histogram to figure out some ideas of this shape. So I'm going to go ahead and give myself a different color. And if you were to go ahead and draw a curve along these like vertices in a way of these boxes, hopefully you agree that it would look like that. And so this has a certain shape to it, all right? And it's going to give us a lot of information. So just looking at a histogram, I should be able to tell where the median is, where the mode is, and all these things that we're going to talk about in this section. So there's different shapes of a histogram. One is unimodal, and that just means you have one mode, and that will make more sense in a second. So it would look something like you have just your axes, and it's just like one peak. Okay, so just one peak. I'm going to write one peak. Where bimodal, you got it, would be two modes. And again, I'll talk about what modes mean in a second. And so that means you have like two peaks. And then your last definition for this one is multimodal, which just means many, right? Just many modes. So you'll have multiple peaks, more than two. Because if it was two, we'd claim it as bimodal. So here's a peak, here's a peak, here's a peak. Something like that. Okay, so if we're looking at the histogram that we just created for the exam scores, I think it's fair to say that this one is unimodal because I only have one peak. All right, the other way we can describe the shape of a histogram is if it's symmetric, it will look like, let me get out of there. Here we go. If it's symmetric, it will look like what I just came up with actually, but it doesn't have to be unimodal, okay? It could have two modes, but symmetric just means you have this peak and the tails on the end are even, okay? Where skewed to the left, this one means you have a tail on the left side. So it looks like this. I take a little bit, my data is growing, then I have my peak. So for these, I'm just drawing unimodals. Why is that stuck there? Don't be there. Skewed to the right would be something different. It would be, you have a tail on the right, and then you peak. Okay? So this is known to be longer tail on the left. That's how you describe left skewed to the left or left skewed data. And this is your longer tail on the right. So out of these three new definitions, if I go back up to this histogram, what do you think it would be? Would it be symmetric, skewed to the left, or skewed to the right? And it would be skewed to the left because my tail is longer on the left side. Okay, needs a little work. Okay, we're going to stop the video here and we'll come back to do more definitions.